right, let's see. For this one, we're going to go over page 233 for day number 2. So this page. Let's go to the first question. Number 9. Let's see. We're going to be using our model, our figure from page 232 that is separated for us on this side. Number 9 says, look at model it right here. What can you say about the two triangles that are part of the trapezoid? They have the same. They have the same base, and they have the same height. We also can say they have the same area, but we don't need to put too much in that answer. Just the basics. Number 10. How do you know that one of the sides of the right triangles is 2.5 inches? For number 10, I explained it a little bit on the last video for page 232, where we said that the whole base is 10, and we take away 5 from there. Just because this side is 5, so when we take it away from here, it's like losing 5. When you do 10 minus 5, you get 5. That means we only have 5 left over for here and here for 2 spots. So we need 5 to be able to go here and here. When we divide 5 by 2, because we have 2 triangles, we get 2.5. And that's how we got 2.5 for each base. But for the question, it's just asking, how do you know one of the sides of the right triangle is 2.5? We divided 5, which was the remaining base, by 2 triangles. Number 11 says, explain how to calculate the area of the large trapezoid. Show your work. We don't have to do number 12. I don't like that question. Number 11 says, explain how to calculate the area of the large trapezoid. Show your work. So for this one, we're actually going to do that part of the work. So let me erase. Let's see how far we can go back, if not. Okay, that works. So we have to calculate how to find this area right here. So let's actually see if we can zoom into this. Sorry about that. It takes forever sometimes, but it's free. So how do we find the area of this trapezoid? Now that it's split up into 2 triangles. My pen up here. Now that it's split up into 2 triangles. So this triangle here, and this triangle here, and this rectangle in here. So let's start off by doing the easier one, which is this rectangle one. So we're going to do our base area, base 5 times height. So let's do this one first. So base times height. 5 times 4 is 20. That means that our area would be 20 inches squared. That's one area. Now we need to do the area for the other triangles. Now for the other triangle, like color coding. Let's see. So for this triangle, we're going to do base, which is this right here. This is our base. This is the base for this triangle, but they have the same base, which is 4. So this base is 4, this base is 4. And now for our height, it's 2.5 for this triangle and 2.5 for this triangle. This is our height. I know it's in the bottom. I know it's like laying on this part of the triangle, but our base is always this part of the triangle. Our height is the one that goes kind of up and down. So it's 2.5. So we're going to have to do our area for our triangle. So that's 1/2 times base times height. So we have 1/2 left over. Base is, like I said, 4 inches. And our height is 2.5 inches. We need this darker. Probably here. Now, when we continue doing this, let's see thick. Let's see. Yeah, that works. So now we can do, what is half of 4 inches? What's half of 4? It's 2. Half of 4 is 2 inches. And then we multiply that times 2.5 inches. For this one, do your work, please. Don't use a calculator. I know you can use a calculator. 2 times 5 is 10. Carry the 1. 2 times 4 is 4. Plus 1 more is 5. 1 decimal spot. We skip 1 decimal spot. That means that would equal 5. Our area would equal 5 inches squared. for each triangle. So this triangle here is 5 inches squared, and this triangle here is 5 inches squared as well. From here, we're going to add up our 3 areas. We're going to add them all up because we want to know what the total area is for the trapezoid. All right, so what do I do here? What do I do from here? I feel like I lost it. Is it that? Nope, it's not that. Where'd you go? All right, well, give me a second. I lost my pen. Oh, there it is. Perfect. Oh, okay, cool. Now, from here, we're going to add our 3 areas. 20 plus 5 plus 5. And all of these are inches squared. I'm not going to put it in there. So 20 plus 5 is 25, plus 5 more is 30. So the area for this whole trapezoid would be 30 inches squared. All right. And let me finish it there. So when you show your work on this side, not this side, I gotta get used to these windows. When you show your work here, it says, what is the area of one of the, I'm sorry, number 11, what is the area of the larger trapezoid? Which would be this whole thing right here. Don't do number 12. I know the book is trying to have you do a challenge question where you find a smaller version of the area inside the trapezoid, but you'll be doing that later on anyway, so there's no point in doing it right now. The 2 questions I do want you to focus on is number 13 and number 14. Now, when you do these 2 problems, they're going to be done differently. 13 needs to be split up into 2 triangles, and 14 needs to be split up into a rectangle and a triangle. How we can do it right now. So let's go ahead and do number 13. But I guess I'll try doing them with different numbers like that. You guys don't have the answers for everything in this book. So let's start off with number 13. Let's start off with number 13. Let me save this real quick, actually. Let's see. This is page... This is not page 4 anymore. This is page 233. I don't know why I have it like that. Page 233 for iReady. No, we actually need one for... I guess pause packet. Here we go. Let's put a JPEG version of that. All right, so let's go with that picture. We just screenshot it. It wasn't that one. It wasn't that one. It was this one. So for this one, like I said, we're gonna have to separate this into 2 triangles. 2 triangles. So if I zoom in here, how do I zoom in here? All right, there we go. Canvas size, 3000. So for this one, we need to find a triangle for, we need to find the area for this whole parallelogram. Not parallelogram. What is this called? Give me 1 second. Use what you learned about finding the trapezoid, find areas of the trapezoids below. Trapezoids. Now we need to make this into 2 triangles. So you can do it like this. When you draw a line this way, oh wait. You can do it like this. Let's see. Oy. See, they have that ruler tool. Oh, I never used this before. All right. Oh, that's pretty cool, I guess. Let's see. So, oh, I can stay in line. Cool. So we can do it like this, where we do one triangle here, or we can do it the other way. I'll use my trusty tool over here. Let's see. Almost there. We can make a line going this way. And I'm gonna do it this way. No real reason, just I picked this way. So we have this triangle here and we have this triangle here. So if you notice that this right here, we have our height already, it's 7.5. If you notice our trapezoid here, this angle is slanted. So this slanted angle wouldn't be our it wouldn't be our height. This side right here wouldn't be our height or our base, I mean, for this triangle. So this side, even if we did know the measurement, we couldn't be able to use it. For sure, we'd be able to use 4, but this one right here, we would have to switch it up. So actually, let's use our ruler tool. Our height would actually be, oh, that could have been a good teaching moment. All right, up and down like this. So I'm gonna make it dotted, slashed, I mean, just so it can mimic what we did in class. So for this one, yeah, I have it ready. Our height would be right here. And we can still use it. There we go. So for this triangle, we would do 7.5 times 3 times 1.5. And then for this triangle, we would do 4 times 7.5 because it's the same height as this one. So 4 times 7.5 times 1/2. So the formula should look like this. So let's put some stuff in here. So this will be triangle 1, and this will be triangle 2. So when I solve this for triangle 1, which is this one right here, we would do 1/2 times the base, which is 3, times the height, which is 7.5. And then for the second triangle, we would do 1/2 times the base. And here the base would be this bottom part of the triangle. Or I mean, it doesn't matter which one you use, but like since I'm using this triangle, I know that half of 4 is 2, so I'm actually going to put 4 first, so it makes it easier for us. Times 4 times 7 and 1/2. Now this is how you solve for each triangle, and then you would have to add up both areas up. Once you have the answer, you would have to add up both areas up. But like I said, I'm going to give you a problem with different numbers. So like that, you guys can do this one on your own. So, oh wait, let's just go backwards. Here we go. Come on, come on. Cool. Now let's go ahead and erase this, and let's go with a different number. So instead of 3 yards, let's see. Instead of 3 yards and 7.5 and 4, let's do 4 yards. This one will be 5 yards, and then this one will be 6.5 yards. Okay, so excuse me. Triangle 1, and triangle 2. To find the area of triangle 1, we do the base. So, I mean, the area would equal 1/2 times the base. So we can pick 4 or 6, which is 4, times 6.5. And then the triangle 2 area, it would be area equals 1/2 times base times height. So the height would be 6.5, and then 5 on the other side. For this one, we're going to do it this way, just so I can show you both ways. So let's do this one up here for triangle 1. And we have colors, so let's use them. There you go. So 1/2 of 4 is just 2, and then we multiply that times 6.5. Remember that 6.5 is a mixed number. We need to make it into an improper fraction. When we do that, we do the bottom part is when we multiply 6 times 2, which is 12, and then we add 1 more. 6 times 2 equals 12, plus 1 more equals 13. Our denominator stays like this, like the 2, so we have that as a denominator. Every whole number, we got this from here, every whole number that's by itself, we know has a 1 in the bottom underneath it. And once we have this, we can actually multiply out the top part. 2 times 13 equals 26. 2 times 1 times 2 equals 2. When we divide 26 by 2, we get 13. That means that our area would equal 13 inches. Oh, it's not inches, we have yards there. YD, so yards squared. That would be the area for our first triangle. So we should call this like area 1. Here we go, area 1. Now for this one, triangle 2, we have half of this. So before we start, we need to make this 6.5 into an improper fraction. So we're going to do 6 times 2 equals 12 plus 1 more equals 13. Bring down the 5, and we bring down the 1/2. This 5 is by itself, whole number by itself. Like I said over here, every whole number by itself needs a 1 in the bottom. So we're going to do that for this one as well. Now from right here, we can multiply across all the numbers out. So we can multiply the top numbers, and we can multiply the bottom numbers over here. Top numbers, 13 times 1 equals 13. 13 times 5. If you don't know that, what is 12 times 5? 60. Add 5 more, 65. Anytime I multiply by 13, I multiply by 12, and then I add up whatever my number I'm multiplying with. So for example, 4 times 13. 4 times 12 is 48, plus 4 more is 52. Anyway, 2 times 2 equals 4. We have an improper fraction. We need to divide it. So we're going to make it into a whole number and a fraction on the side. So this time, I can't do, when I divide, I'm not going to get a perfect number. Actually, I'm going to get a fraction left over. So we're going to do 65. We're not going to have enough space there. Let's make it smaller. 65 divided by 4. 4 times 1 is 4. Bring down the 5. 4 times 5, 4 times 6, 24. 4 times 5, no, 4 times 6. 4 times 6 is 24. I get 1 left over. We're going to add a decimal because we're going to add a 0. It's a horrible decimal. We're going to add a 0. 4 times 2 equals 8. And we have an infinite loop. Yeah, no, we don't have an infinite loop. 4 times 5 equals 20. We get a 0. We usually only go up to 2 decimals. But for area number 2, we have 16.25 yards squared. Now that you have both of these triangle areas, you're going to have to add them up. You know what that means, different color. So we're going to add this one plus this one. So we are going to, let's do it a little bit confusing. So 13 plus 16.25. And look how I lined up my decimals. Every whole number that has no decimals basically has a decimal point right here at the end. That's how I know how to line them up. When I add this, having the zeros there, I get 29.4. That means that the area of this whole trapezoid, is 29.25. So the area of the trapezoid, I know my writing is horrible, is 29.25 yards squared for that whole trapezoid. So let's go ahead and save that. Let's see, that's page 234, example number 13. Like it. It's not the actual problem. Now, for the other one, let's go ahead and do it for number 14, I believe. Let's see, where are we at? Wasn't that? There we go. All right, let's see. I think I figured this part out. Yeah. Oh, no. I think I just got to zoom in here, though, and it'll zoom into the left side. Whoa, too much. All right, that's good enough. Let's make it a little bit bigger, actually. I actually want to... I can just move this up here. All right, here we go. Image, canvas, let's make this 3000. Yeah, I know. All right, here we go. So for this one, we need to separate it into a rectangle and a triangle. Oh, I love using this tool. So let's use this ruler tool. You gotta admit, this free program is pretty good. All right, so let's see. We're gonna put you right here. We'll make it as straight as we can. I guess I need to get to angle 0. There we go. And then again, we're gonna make our height here, but we're gonna make it invisible. Let's do it with the other. Now let's do it with green. It's fine. So this will be our height of this triangle. And this will be our base for this triangle. Or this can be our base and this can be our height. Either way, the formula answer is still the same. So it's gotta be. I can go back to the last color I was using. The area for this rectangle, it's gonna be this side times this side. So it's gonna be 3.2 times 4. 8 12, 1 decimal spot, 1 decimal spot. So the area for this rectangle is 12.8 centimeters squared. Now the area for this triangle, that part's kind of tricky. We need to figure out what is this side. Ooh, let me get another color. Is how much is this side worth? So we know that this whole thing, is 6. We know that from here to here it's 6. So we're going to take off this 4 part. We're going to subtract 4. So essentially we're taking out, like we're deleting this, and we only have this part left. So this whole thing is 6, and when we delete 4 from it, we get 2. That means that this part would have to be 2. And our height is the same as this, or base, whichever it is. So this side would be 3.2. So now we need to do 3.2 times 2, and then times 1/2. Now, let me do that with, let me actually write that out. So our area for this trapezoid, for this triangle would be 1/2 times the base, I'm just putting whichever number, and then 3.2. I know that half of 2 is just 1. So when I multiply 1 times 3.2, my area is just 3.2 centimeters squared. Now, this means that I need to add up this area plus this area. So when I do that, it's 12.8 plus, remember, line up your decimals when you're adding, 3.2, 0, carry the 1, 3, 4, 5, 6, 1. So that means that our answer would be for this trapezoid, the area of the trapezoid, area of the trapezoid is 16, that looks like a 15, is 16 centimeters squared. You would put that answer right here. We're sure to work there. Now, I'm doing it in Canvas, and I need a lot of space, so I would want you guys to please do this on a scratch paper and just staple it or just keep it in order with the rest of this. If you guys don't know, you guys do need to take pictures of your work and be submitting it through ClassDojo, through that Google Voice number we gave you, through the school, or Google Classroom. I'll be setting that up later. Yeah. That's it for today.